Solutions to Factored Form Part 3. In this video, you'll learn why multiplying a sum and a difference, like x plus m times x minus m, results in a quadratic expression with no linear term. The difference of two squares is a method of factoring when the quadratic expression contains two squared terms. So if we have a plus b times a minus b, then we can write it as a squared minus b squared. So if we have an example like x plus 5 times x minus 5, then a will be considered x, and b will be considered 5. So we can write this as x squared minus 5 squared, or 5 squared can be simplified to 25. Now let's just double check that this method works by expanding our original problem. So we'll multiply our x plus 5 times x minus 5, which gives us x times x minus 5 plus 5 times x minus 5. So we'll distribute each of the blue terms to the parentheses. And this gives us x squared minus 5x plus 5x minus 25. We'll combine our like terms of negative 5x and positive 5x, which just gives us 0. So we're left with x squared minus 25. And this is exactly what we found by using this method, so this method does work. In this example, Claire claims that 10 plus 3 times 10 minus 3 is equivalent to 10 squared minus 3 squared, and that 20 plus 1 times 20 minus 1 is equivalent to 20 squared minus 1 squared. So we can find out if Claire is right by taking both of her expressions and simplifying them to see if they give us the same answer. We'll start with the terms with 10 and 3. So we have 10 plus 3 and 10 minus 3. If we add 10 and 3, we'll get 13, and if we subtract 10 and 3, we'll get 7. Multiplying these together gives us 91. Now let's look at the other expression of 10 squared minus 3 squared. 10 squared will give us 100, and 3 squared will give us 9. When we subtract 100 minus 9, we get 91. So we can see that this gives us the same answer. Now let's look at our other expression. So we'll take 20 plus 1 times 20 minus 1. Adding 20 and 1 gives us 21, and subtracting 20 and 1 gives us 19. When we multiply these together, we get 399. Now let's look at our other expression. If we square 20, we get 400, and if we square 1, we get 1. So 400 minus 1 gives us 399. So this matches as well, so Claire is correct. Now we want to know if x plus 4 times x minus 4 is equivalent to x squared minus 4 squared. So we'll take the expression they gave us and we'll simplify it to see if we can get it to x squared minus 4 squared. We'll start by multiplying our first parenthesis by the second. So this will give us x times x minus 4 plus 4 times x minus 4. We'll distribute the x and the 4 to the parentheses, which gives us x squared minus 4x plus 4x minus 16. We can combine our like terms of negative 4x and positive 4x, so we would just get x squared minus 16. 16 is the same as 4 squared, so now we can see that it is equivalent. So if x times 4 times x minus 4 is equivalent to x squared minus 4 squared, does that mean that x plus 4 times x plus 4 is equal to x squared plus 4 squared? So let's take this expression and we'll expand it to see if we can get it to x squared plus 4 squared. We'll multiply our first parenthesis by our second parenthesis, so this gives us x times x plus 4 times 4 times x plus 4. We'll distribute that x and the 4 to the parentheses, which gives us x squared plus 4x plus 4x plus 16. We'll combine our like terms of 4x and 4x, so we get x squared plus 8x plus 16. So this is not equivalent. When we add them, our middle term actually doubles instead of going away like we've seen when we're subtracting. So we can't apply the same property when we're adding. Now we're going to complete the table so that each row has a pair of equivalent expressions. So some of them are given in factored form and some of them are given in standard form. Let's start with x minus 10 times x plus 10. So a is considered x and b is considered 10. So we can write this as x squared minus 10 squared. 10 squared is the same as 100, so we'll simplify that. Now let's look at 2x plus 1 times 2x minus 1. This time a is 2x and b is 1. So we can write this as 2x squared minus 1 squared. 2x squared can be simplified to 4x squared, and 1 squared is just 1. Now let's look at x plus the square root of 5 times x minus the square root of 5. This time a is x, and b is the square root of 5. So we can write this as x squared minus the square root of 5 squared. When we square a square root, it will give us a whole number under that radical, so this can simplify to x squared minus 5. Now we'll take x squared minus 81 and put it into factored form. So we know that it's in the form a squared minus b squared. So that must mean that a is x and b is 9, since 9 squared will give us the 81. So we can write this as x plus 9 times x minus 9. Now let's look at 49 minus y squared. So we have the same format, so if a squared gives us 49, then a must be 7, and if b squared gives us y squared, then b must be y. So we can write this as 7 minus y times 7 plus y. Now we have 9z squared minus 16. So if it's in the form a squared minus b squared, then a must have been 3z, since 3z squared gives us the 9z squared that we have. And b must be 4, since 4 squared gives us 16. So we can write this as 3z plus 4 times 3z minus 4. In this example, we're going to use the differences of squares to simplify each expression. So we know that they're all going to be in the form a squared minus b squared. If we look at our first example, a is y and b is x. So we can write this as y squared minus x squared. Now let's look at the one below it. So a is 11 and b is x. So we'll replace a with 11, and 11 squared can simplify to 121, and b will turn into x. So now we have a simplified version for this expression. Now we'll look at x minus 11 times x plus 11. So a is x, and b is 11. So a will become x, and b will become 11, and 11 squared is still 121, so we can simplify this. Now let's look at our last one. A is x, and b is y. So a becomes x, and b becomes y. In our last example, we're going to write each expression in factored form if it's possible. So we'll start with x squared minus 144. We'll use our format of a squared minus b squared to find what a and b are. A must have been x, and b must have been 12, since 12 squared gives us 144 that we have. So we can write this as x minus 12 times x plus 12. Now let's look at x squared plus 16. If we look at our form of a squared minus b squared, we see that we subtract the terms instead of adding them like we have in our expression, so this one is not factorable. Now let's look at 25 minus x squared. So a must have been 5, since 5 squared gives us 25, and x is equal to b. So we'll write this as 5 minus x times 5 plus x. Now we'll look at our last example, but if we look at our expression, we can see that they're adding again, so this one is not factorable. So let's summarize what we've learned. Quadratic expressions written in the form a plus b times a minus b can be rewritten as a squared minus b squared. This only works when it's a difference of squares, though, not for the sum of squares. This method helps simplify expressions and solve equations more quickly and efficiently.